Hey everybody, it's Mr. Combs, and I wanted to talk to you about an example of proving an argument is valid. And please excuse if you hear any noise outside there. Having a class outside tonight. This is an English night for Tuesday Night Live. So I thought that I would talk a little bit about what an argument is and how we prove that an argument is valid. So let me see here. I'm going to try to, get our document to be a little bit bigger. All right. So an argument is a series of statements called premises or premises, followed by a statement called the conclusion. So an argument is valid if whenever all premises are true, then the conclusion is also true. So an argument takes the following general form. I've got, let's see here. I've got a premise, one or two premises, and then a conclusion. And these three dots in a triangle, that stands for the word therefore. T-H-E-R-E-F-O-R-E. And excuse my writing with my mouse. But so an argument takes the following form. So you have premise 1, premise 2, and then therefore the conclusion. So to verify an argument, you're going to write it symbolically first, join the premises together using and. You're going to form a conjunction. Remember, and is this symbol. Then you're going to form a conditional statement using the conjunction as the hypothesis and the conclusion of the argument as the conclusion of the conditional. Form a truth table. If you have a tautology, that's one that's always true at the end. The argument is valid. So let's look at an example. Here is a situation that we can see if this argument is valid. If you have a value card, you get a discount at Food City. You did not get a discount at Food City. Therefore, I'm going to conclude you do not have a value card. All right, so first of all, let's write this argument symbolically. I'm going to say that you have a value card is my statement P. And I'm going to say you get a discount at Food City is the statement Q. So if I want to write this premise symbolically, I would say if P, then Q. So P, arrow, Q. So that means if P, then Q. Then I have you did not get a discount at Food City. So if you get a discount at Food City is Q, you did not get a discount at Food City is not Q. And remember, with the not, we use a tilde. So therefore, I'm going to conclude that you did not have a value card, so not P. So what I'm going to do is I'm going to join the premises together using and. So I'm going to say, first of all, just a second, I've got some reminders here. What? Dismiss all. Okay. Okay. So I'm going to say P, or if P, then Q, and not Q. So I'm going to join all of the premises together using and. So I had two premises and I've joined them using and then I'm going to write that in a conditional with the conclusion. So what I'm saying here is if P then Q and not Q, that implies that not P. Okay? So if I have if P then Q and not Q, then not P. So now what I'm going to do is create a truth table to see if I in fact get a tautology or an argument that is always true. So I need a P, I need a Q. In my arguments, I need a not P, I need a not Q, I need an if P, then Q, I need an if P, then Q, and not Q, and finally I need this whole thing, if P, then Q, sorry about my writing with this mouse, not Q, and not Q, then not P. So this, let me change my, so this whole entire statement is what this is, and I know that this is hard to see. Alright, so, or it's hard to make out because of my poor writing skills with the mouse. So remember that we have true, true, just a second, let me get rid of this. So true, true, we can have true, false, we can have false, true, or we can have false, false. Alright, so now I'm going to fill out the truth table. So I have not P. So remember, not P is always the opposite of P. So if not P is true, or if P is true, not P is false. So false, false, true, and true. Not Q. So if Q is true, then not Q is false. So now I have false, true, false, true. Now remember, this is a conditional. If P then Q. The only time that if P then Q is false is if P is true and Q is false. Okay? So if P then Q. So if P then Q. So P and Q are both true here. So if P then Q is true. Here I have P is true and Q is false. So that means that's false. Here I have P is false and Q is true, so that's true. Here I have P is false and Q is false, so that's true. Now, if I have and, remember that and is false unless both of the components or both of the statements are true. So I'm looking at, for this one, let's see, let's use blue. I'm looking at P, if P then Q, and not Q. So false, true, that's going to be false. False, true, that's going to be false. False, true, that's going to be false. And true, true, that's going to be true. Okay, now I have the premises and the conclusion, not P. So remember, if the premise is true and the conclusion is, or the hypothesis of, this is the hypothesis of an if-then statement. So if the hypothesis is true and the conclusion is false, that's the only time that a conditional will be false. So here I have false, false, so that means that's true. Here I have false, false, that means that's true. Here I have false, true, that means that's true. And here I have true, true, that means that's true. And look, I have a tautology. It's no matter what the truth value of P and Q are, in this case, this statement is always true. So this is a tautology. The argument is valid. So I hope that was helpful. I will see you next week.